The third case is of equal functions. So here let us assume two functions, one as f, the other function as g. They are defined on the same domain, that is capital D. They are said to be equal sets if and only if f of x must be equals to g of x. Then it can also be written as f is equals to g. So here two functions we are going to assume, say f and as well as g are defined on the same domain. So here the domain of these two functions must be same. So it is defined on the same domain, are said to be equal functions if and only if f of x must be equals to g of x. So here for all x is belonging to the domain, that is D. Say here it can also be written as f of x is equals to g of x, can also be written as, so it can be written as function f, that is f is equals to function g, that is f is equals to g. So here f and g are of equal functions. Then now let us illustrate one example under this. So here the illustration is of we have to assume two functions. So first function is of f, that is except one, that is reals, the domain. So here into the reals be defined by f of x is equals to x plus 1, and the second function, that is g, is also except 1, the domain is of same, so that reals except the 1 as the reals of the domain. So here into R be defined by g of x, the function is of g of x is equals to x square minus 1 overall divided by x minus 1. So here we have to show that functions are of equal, that is function f is equals to function g. So we have to prove that these two functions are of equal, that is equal functions. Then now the solution starts, or in other words, so we have to prove it, f is equals to g, therefore the proof starts now. So in our proof it is clearly observed that in the functions g, f and as well as g, the domain is of except 1, the real in the first case, and domain in the g is also of except 1 in the reals. So here as per problem, so function f is real except 1 as the domain to R, and so g is a function domain except 1 as the real into R. The function f of x is given by means of, so x plus 1, whereas here g of x, the second function, is given by means of x square minus 1 overall divided by x minus 1. But here equal functions can be defined by means of on the same domain. So here domain of the function f, so here let us find out the domain of f is equals to except 1, the reals, the remaining. So we can take as here, for instance, 2, 3, 4 and so on. Then now here, say here domain of g, that is the function g, is given by means of, so except 1 the reals, so we can take 2, 3, 4 and so on. So here I want to find out f of x. So here f of x is equals to x plus 1 is the first function, that is function f. So here I want to assume the domain as 2. So here at x is equals to 2. Then now, so that implies, so f of 2 is equals to, x must be replaced by means of this 2. So here 2 plus 1 which is equals to 3. So in this manner I got f of 2 is equals to 3 in the first case. Whereas in the second case, say let us write this as case number 1 and this as the case number 2. And in case number 2, the function g is of, so here g is equals to x square minus 1 overall divided by x minus 1. So here, so g of x, so it is of g of x is equals to x square minus 1 by x square plus x square minus 1 by x minus 1. So here let us assume the same domain, so that is 2. So here at x is equals to 2, when we replace x by means of 2, so here that implies, so g of x is replaced by means of 2, that is g of 2 is equals to, x must be replaced by means of this 2, that is 2 square minus 1 overall divided by x again replaced by means of 2, that is 2 minus 1. 2 square value, 2 into 2 is of 4, minus 1 written as it is, overall divided by 2 minus 1 is of 1, that is equals to 4 minus 1 is of 3, overall divided by 1, that is equals to 3 by 1 is of 3. So in this manner we got g of 2 is equals to 3. So here therefore g of 3, so g of 2 is equals to 3. So in this manner we got, so here f of 2 is also of 3, then now g of 2 is also of 3. Then from this it is clear that when the right hand sides are equal, then the left hand sides must be equated. So here in the next logical step, f of, since f of 2 equals to 3 and g of 2 is also of 3, so here from this, so let us assume the first one as the first equation, then the second one as the second equation, then from 1 and 2 equations, it is clear that the right hand side quantities are equal, therefore the left hand sides must be equated. So here from this it is clear that, so here f of 2 is equals to g of 2, that is f of x is equals to g of x. So here hence, so that implies function f is equals to function g. So here hence function f and function g are of equal functions. So here therefore function f is equals to function g, hence it is proved.